Hello again, everybody. So, before we move on, let's make sure everybody understands the flow of a web request, the code that runs, and how the browser gets its response back. And Harper actually texted me at the break. He said, you know, we're covering kind of all of web development with introducing Node.js, and it's kind of required. This is the first time you're seeing it all put together. So you probably had questions up to now. How does it all work? This is how it all works. That's why it's the first time you're going to see it. That's also why we're kind of glossing over it, and I didn't expect it to take this much time, is because we do this every day, and it's kind of understood. But I forgot that this is the first time you all have seen this. So let's do it again. Web request. Let's see if I can. Nah, I don't even have Visio. I need to install more things on this computer. So let's talk about the overall web request, running code, and responding. And we're going to use some technical terms because you're going to need to understand them to be able to talk with other developers and to be able to get through an interview if you're going to be a web developer. So where does it all start? Somebody opens a web browser, types in a URL, and the URL is server name /play. That's the URL they typed in. What happens? Walk me through it.
So that play is the specific route.
Play is the route, and the server name is, that's where we're going to go find what we're talking to. So how do we go find that server name? Google.com or whatever you have.
First, your application server, so whether it's Node or whatever, sends out a message or a request to the DNS server.
It's this is why we're going through it. So step one is the browser requests something, and it's google.com. The browser says, okay, I need to understand the IP address because I can't really talk to google.com. There's no servers named google.com. It's always IP address. So DNS, it does DNS resolution. It says, okay, it's 107.53.23.97, whatever. It gets the IP address, and that allows the web browser to go talk with that computer. That's where it says, web server, I'm requesting /play from you. So by the time it gets to the web server, you've already resolved DNS, you've been routed through the internet routing, gets you to the right server to receive that request. I typed in google.com or whatever it is /play. So the route is play. The destination is the web server. We got to the web server through DNS resolution. So the web server receives it. Now the web server, it's a little bit confusing because you use the same term for two very different things. One is the computer, like the physical computer, like you plug it in, unplug it. That's a web server hardware. Developers don't care about that. When developers talk about web server, we're talking about the software running on that computer that is listening to a specific port. Okay? So when I say web server from now on, probably I'm meaning the software that's running and listening to a given port on that computer. So let's talk about that. So the web server says, oh, they want a route. I said server name /path /play. So the play is the route. Play is passed to my application. Okay. Normally you don't have the port. Anybody? Why am I trying to confuse you with the port? Because when you're a developer, you might have multiple development web servers running locally. Each one has to listen on its own port. Think of it as TV channels. You can't have two programs running on the same TV channel at the same time. That's why normally if I'm doing Node.js, I use port 3000 or 4000 or 5000. If I'm doing Elixir, I'll use port 4000. If I'm doing Ruby, it's 3000. TypeScript, I'll use 4200. So I can run multiple web servers locally, which in the real world you wouldn't do. But locally as a developer, it depends on what I'm doing that day. So I could just leave it off. If I typed in port 80, let's do that. I'm going to show you that it's not all just theoretical. Right here, this is our route example, app.js. How does it know which port to spin up? How does it know where to listen? It's hard-coded in here. It's saying, I'm going to make that 80, just so we eliminate some of the confusion. So I'm going to save that file, and this is example routes. Example routes, node app. It's on port 80. Now, I could do this. I could do that, but that would be extremely redundant because the default HTTP port is port 80. It works. There's nothing magical about ports. That's just a way for developers to say, so that I don't conflict with other ports that may be running on my computer, I'm going to put it on this port for development purposes. Okay? So, we've got this server name /play, I think is the route that we decided to play with. What happens then? The web server is given the request, and it's given all the details about the request. Over here in Postman, we saw that if you're doing a post HTTP verb, you can send a payload of data. Where does the post come from traditionally? Back in like 1993, posts existed. What were they used for? Anybody know? It's that old contact me form. You know, it's back on like 1993. They still had a contact me page where you had first name, last name, phone number, email address, and there was a submit button. They actually said submit down there because that was the default. Submit. When you post a form, it's called posting form because it uses the HTTP verb post by default. And it'll send it to a URL on a web server. So what I'm teaching you is really old. This isn't brand new with Node.js. This is how the web works. This is how dynamic applications have worked for 20 years. This is just your first time seeing it. So when I click that submit, PHP, Kelly does PHP, I'm telling on you a little bit. So PHP works the same way. What's the web server in PHP that you use most often? Apache. So you've got Apache run on Linux. It's got a little PHP application. And that's why I'm trying to show you in different technologies, they all do this the same way, which is why you need to understand it. So this is just the Node happens to be the first one we're talking about. So PHP runs in Apache. Apache is the web server. So /play. Your PHP application is tapped on the shoulder. It's like, here, somebody wants the play route for your application. It's up to the PHP to decide what to do with that. You run some PHP code. Most often in PHP, you could query a database. You could have some if statements and create, what does a browser speak? We got to send something back. And most often when you're talking web stuff, it's a browser making the request. Safari, Internet Explorer, Chrome, what have you. So what do you send back to a browser?
What you request.
What does a browser want to see?
HTML.
HTML. Yeah, you know this. That was like day 2. So HTML, it also speaks what other things? CSS. What is it? Also speaks JavaScript. Okay. So all we're going to do, the server side can be as complex. You can do PHP, Elixir, JavaScript in Node. You could do C#, whatever you want. Java, JSP pages. All of that runs on the server because you have special things installed on the server that allows it to do some pretty interesting things. The end result, the common denominator, when that's done, we're sending back to the browser HTML, CSS, and JavaScript. There's nothing else that the browser is going to understand. So we can be as crazy as we want on the server. We can call database queries, run 10 store procedures, send emails, whatever you want. At the end of the day, all the browser cares about, getting back to the big conversation, the web conversation. We requested a server. We requested a GET on the route play. It tapped our code on the shoulder. Please respond to the route play. Your application runs whatever code it wants, and it sends back something appropriate. At the very least, we learned about HTTP codes, right? HTTP status code responses. So, HTTP cat. So if your application fails, you have an internal server error, you'll get a 500. If they request something that doesn't exist, not found, If you are successful, it's a 200. So this is actually use this site sometimes to look up some obscure HTTP status codes that I might get from a web server, like a 503 or something, you know, service unavailable. So these are HTTP status codes. You'll always get one of those back. Whatever else you send back, like if you don't specify 200, if you send back, here's some JSON or here's some HTML or CSS, it's 200. It's success. You're good. You could send back other status codes if you want. You are in control. You're in the driver's seat as the server, web server application developer. Everybody else is your clients. All those users on the website. Facebook.com. How does that work? It works this way. They have a bunch of code that runs on the server at different routes, but it works exactly this way. So I want the light bulb to go off in your heads. You could go home and you could write the equivalent of Facebook.com too, if you want. It's not hard. You could write Twitter.com. What is it really? It's a web page, probably a native app or two, that are just user interface against server-based software that you can choose whatever technology you want that talks with the database. What have we not taught you? Just that middle tier. It's all up to your creativity now. So let's talk about some specifics. Hopefully that's inspiring you to actually pay attention and get this and ask questions. So port 80, Facebook developers are in their nice plush campus over in California somewhere doing this right now. Google developers are doing this right now. There's no difference to what we're learning today. So we've got routing. This Express just says, I'm going to make it easy for you as a JavaScript web developer on the server side to respond to different HTTP verbs at different paths. That's all it's doing. So we can say, you know, is there a delete? Yeah, there's a delete. That just means when somebody sends a delete verb to the home path, I want this function to run. What's most often you're going to do? You need to respond. You need to send something back. But how you respond is completely up to you. I'm sending some nasty little text here. The browser doesn't really speak text, which is why it shows up in a big white background and just like typewriter up in the top left. If I want to make it look pretty, send HTML and CSS. You don't want to write all your HTML and CSS in here. So let's go back to the most complex example we had in this routing, which is P2. It doesn't look very complex, does it? When you have a function that responds, and I'm going to introduce a term here. When you have a function that responds to a web request in a web application, it is often called an action. It's just another term. You know, method is a function attached to an object. When you have a function whose purpose in life is to respond to a web request, it's often called an action. So this is an action. And you're going to see that term again in ASP.NET MVC and in Ruby. What are we doing? We learned some JSON. We know JSON. This is just JavaScript. Remember when I was kind of harping on you, is like, remember how to do your object syntax. Because you could have arrays here. You could do whatever you want. You could have an array of nested objects. You could have nested arrays. Now we're getting a little crazy, but do whatever you want. Okay? Why do we care about an array of objects most often? We talked about the metaphor when we were talking about databases. An array of objects is how you say in JavaScript, give me a table, like a row, because the table itself is the array. Each row is an object, and each field value is a property in that object. And if you have multiple objects, say you have 10 rows in the table, you have an array of 10 objects. That's all it is. So that's how you map from the database context. To answer Anna's question earlier, how do you get from SQL over to the UI? That's how you map it in JavaScript. You're going to see that 10 times today, so don't worry about it. The point here is I'm introducing a view model. That's just a variable. I could call it X if I want, okay? The point is I'm stuffing a bunch of data into this object. I'm going to give it as many properties as I feel are necessary, and then I'm doing this. RES is, remember, we've got two parameters here. One is request, that means what was I passed. Res is response. So that's what I'm sending back. So it's input output, that's all it is. So the response is I'm going to go render a file as my response. Render is a fancy word that means take a template and resolve any variables in the template and give back the result. So the template here, by convention, it's going to look in my views directory and it's going to find one named P2. And I'm going to pass it. Here's a variable that I want you to use to fill in all your alligator brackets or dynamic content. Jade, and I told you very quickly that there are several different flavors of view engines that you could use in Node.js. That's because it's open source. Somebody decided, you know, I don't really like the alligator brackets. What is an alligator bracket? It's, you know, people are thinking I'm losing my marbles. It's that. That's an alligator bracket. So that is, you're saying in your HTML template or your template, oh, from here to here, I'm going to write some code. Equal is shorthand syntax that says, I've got a variable named this, title in this case, and I want you to take the value of that variable and I want you to plop it right in here. Like look in the variable value and put it in my HTML. That's what that means. That's all it means. What am I doing here? Oh, you can kind of read that. That's just JavaScript. That says alligator bracket. Okay, watch out. I've got some code running. It's not straight HTML. I'm going to have an if statement, and I'm going to say, look to see if message is null. I'm saying if it's truthy. It's shorthand syntax. I'm saying if I should say something like this. That's longhand. It means the same thing. And I'm saying, oh, you know an if statement in JavaScript? There's the end of my alligator bracket. So that says, oh, I've started an if statement. I'm not done yet. So how do you close it? That's how you close it. You just have another little alligator bracket call out. And you say, there's my little curly brace. In between here, I could write a bunch of lines of code. This stuff will be rendered. It'll be sent back as part of your HTML page if message not equal null. That's all that means. So you're saying, if this is true, I'm going to send that little bit of HTML back. One more term that I went over that might have confused people. This variable, I'm calling it X here. I could call it whatever I want. You'll see VM used a lot for view model. A view model is just like a function that responds to a web request is called an action. An object variable used to pass data from your action to your view is called a view model. I know it's hard to get like 10 new terms at once, but you're going to hear it for the rest of the class. So we're going to repeat it. So just write it down, think about it, ask questions, you get used to it.
Say that again.
So this function from here to here is called an action because it's a function that responds to a web request. A method is a function that is attached to an object. This variable, it's an object variable. Why? Because I've got a curly brace there, and I'm saying inside there I'm going to throw a bunch of properties. It's a big bag of data. Think of it as like that. I'm throwing whatever I want in there. Normally, if you're querying a database, it's going to be the rows that you got back from your query. This is where you stash it. So we build a variable that has all the data we want to send, but the data isn't going to be digestible by the browser because the browser, I mean, we could. Let's see what that looks like. I'm going to change this just for a second. What happens if we do this? rest.send VM. You can send that raw JSON back to the browser. Let's see how it deals with it. So what's the route? How do I get here? How do I type that in to go there? just whatever the path is /p2. It's going to show me the JSON as text. That makes sense to you and I as developers, but it doesn't make sense to people. Not that we aren't people, but lay people, I mean. What they want to see is a nice, pretty picture. They want to see HTML tags. They want to see a web page. So you can't just send back your data. Life would be so much simpler if you could. Instead, we've got to actually, let's make it pretty. So you send your data to this view. And what we're doing is we're separating your presentation logic. You front-end developers out there, pay attention. Because this is where you write your CSS, HTML, and JavaScript in the real world. You don't write it in the browser and put it on a static website. Most often, you're part of an application. So you need to give your content that makes your website pop to an application developer. Or if you're the application developer, you put it in your node.js app so that when somebody requests a route, it sends back all your pretty stuff. Where do you put that? They're in templates. They're not straight HTML files because those templates are HTML plus a little sprinkled in variables, your data. You write some nice CSS, where do you put it? Well, you probably put it under static. You probably put it under assets. So let's take a look and let's force ourselves to look at this view engine syntax. I'm not going to ask you to learn this because I can't be bothered to learn it myself. But let's figure it out. Question.
A quick question. So the CSS and HTML pages go within static, not within views.
Correct. The question was CSS and HTML and JavaScript too. JavaScript on the client side in the browser. Okay. Do those go in static or do they go in views? Most often they go in static because all you're doing is you're sending that stuff. It's really code, HTML, CSS, and JavaScript code, but it's not code running on the server. It's running in the browser. So it is static as far as the web server is concerned. Just send it down, the browser will figure it out. You could, if you put it in your view, if I put, like right here, I do have some JavaScript. I have some JavaScript in my view. It's going to render, as long as it's not interspersed with variables, it's going to render just as normal HTML. You could put it here. I'm dynamically adding something to my JavaScript code in my view. That's a reason you might want to put it in your view rather than just a static file. What am I doing here? You know what a JavaScript alert is, right? That's a script tag. That's script type is equal to text/JavaScript, and then you have a closing script tag. It's really weird syntax to look at in Jade, but it says it's going to close your tags for you. That's all it's doing. And you don't have to do the less than greater than. It says inside of my JavaScript tag, I have an alert. You know what an alert does, right? It's going to have a little pop-up box. What is that? That is how we're getting the people riding the airplane off the shuttle bus. That is where we're talking about a variable that was passed to us as the view model. So let's go look at what we called here. That. This is our variable. We passed that property in that variable. We passed that object to P2. We're inside of P2. This is in Jade how you say, I want that property value right here. So let's re-render this. Let's save this. Now that you've kind of seen it all the way through, and P2 I think it is. Why did that happen? Because the view rendered a script tag, and we're going to look at it in view source. Just because we've learned new technology doesn't mean we've thrown away all the old. It's still there. Can you see me? The server says hi there. Let's look at this. View page source. Oh, that's hard to look at, isn't it? Let's look at it in the console. I bet you it'll format it for us. There we go. That's pretty. And let's take a look at... There's our script tag. Notice, pay very close attention. By the time it gets here, you don't see that variable because the browser, it's already been rendered. The browser only sees the result of what happened on the server. That's why you can run a different language on the server than you care about on the client in the browser. So let's go take a look at that code once more, because this is very important to understand the mechanics. Look at this. Hashtag, curly brace, and then I just said variable name. What that's saying in this view engine, it says, get the property on my view model object, insert it here. That's all it's doing. Now, let's see if you understand that. Instead of saying hello there, I want it to say something else. I want to say hola. I change it here.
And it'll automatically bring it in.
Save it. Is there anything else we need to do?
No.
No. The answer is no. It's that simple. Run that again. It says hola. And I'm going to look down here. Look what it did. I don't see that special replacement syntax because the view has rendered. Before it leaves the server, it's already flattened it into HTML, CSS, and JavaScript. So there are no variables in it except for whatever JavaScript stuff you want to run on your client browser. That's why we did it in this order. It is a little bit confusing to see when does my code run. We learned about the front end. We didn't even have a web server. It was all static. But you could write JavaScript, you could run jQuery, and all that stuff is, you can write an application that runs in the browser. Now, the code that we're writing over here in Node, it runs on the server. Everything that happens in Node is done running before the data gets sent back to the browser. You can see our dilemma before we started this course. We were discussing, we do such complicated nonsense. How do we explain this to normal humans? It's like, okay, you've got code that runs on different locations. It could be in the same language, like JavaScript. But you kind of have to understand where are things running, when do they run, what's the sequence. If we threw you into the middle of things, this was day one, you wouldn't get it. Nobody could get it. You have to have the understanding of, let me understand it piece by piece. Today is the first day where you understand every piece. Or you've been exposed to every piece. Maybe you don't understand it all.
It's a relative term.
Yeah.
Understand.
So, any questions about this?
So, this is what's happening already on the server, and that's the big difference between a view and the static. Is that the static is like the blueprint or the format for the browser. That's where the HTML is, whereas the view is something that gets implemented into that before it even reaches the browser.
I'm going to simplify what Scott is reasoning it out and trying to verify that his understanding is correct. You had everything correct, but you went around about. So let me restate it more succinctly. A server-side view has some code and some processing that runs before it gets sent back to the browser. Yes. Static files, like a plain HTML file or a plain CSS file that is given to the browser, does not get any processing on the server, and it gets sent to the browser as plain text. Correct. All of the processing of CSS and HTML and client-side, browser-side JavaScript happens only in the browser. That is not interpreted at all on the server. As an extension, would you ever use jQuery in Node? They're both JavaScript, right?
But you need
No.
No. Why would you need jQuery? There's no HTML parsing. You don't have a span. You don't have divs. Those aren't processed as objects on the server. On the server, it's text. It doesn't care about how your page is structured or rendered. jQuery is what you use in the browser as JavaScript to say, I'm going to talk about that div and I'm going to do something fun on the page. It's not relevant for Node. It's a little bit difficult to understand. Node is JavaScript. jQuery is JavaScript, but they run in different containers. They care about different things. What's in a library that Harper mentioned very briefly that is JavaScript that might be relevant for both your client-side script and your server-side script? It's one that was used for processing arrays. Underscore. Underscore JS. There is an example of a library that's pure JavaScript that sometimes in your jQuery code or your client-side JavaScript code, you want to process arrays and do some fun things and make it easier. You do that exact same thing on the server side in Node. So try to understand both the client-side JavaScript and server-side JavaScript, same language, identical. It is the same engine. What you do with it is different. In Node, you might talk with the database. Would you talk with the database from jQuery directly? No, because there isn't a database platform that's going to open itself up to talk directly from client-side code, most often. Harper's thinking Meteor, and that's a different thing. So, review. Everybody understand the basics of a web request. And, you know, I asked the docents if I should do this, and they said, no, don't do that, and I'm going to do it anyway. Let's see. I'm going to go to, let's find an Elixir app. I don't even have an Elixir app here. I've got real stuff, but I can't show you real stuff. There we go. I can do that. No. It's Node. Swift.
Does that coding example not work?
It's not a web server. The point is I was going to show you Phoenix. Phoenix is...
So the docents were right after all.
Yeah, the docents win. So the point is I was going to show Elixir Phoenix and show you that in a different language, different stack entirely, it does it almost exactly the same way, to the point where you could even read it. It's like, oh, that's a GET, that's a POST. When I receive this request, it's going to run this code. And when it runs the code, what is it going to do? It's going to pass it to a view, and it's going to render the view as HTML and CSS and JavaScript. It all does it that way. I don't have to have Elixir. I can show it to you as C#. Let's do this. View, web. Oh, what do you know? There's a views subdirectory in a C# ASP.NET MVC application. And let's look at CSHTML. That means C# HTML. That's a view. Guess what we have in here? We have a slightly different view engine. They use the @ sign to mean instead of alligator brackets. So this is that little piece, that's a variable. That little piece, that's a variable. But all this other stuff, oh, that's HTML. I understand HTML. You can read that stuff. This is just a view. The point is, they all do it the same way. Let me show you. Yeah. Do I have it? Yes, I do. Some nasty code. Remember that nasty database? There's some nasty code that goes with it. Thank goodness this is going to be soon rewritten. So let me show you alligator brackets in C#. Gotta make sure I have a page. Let's see. What do you know? You recognize that. There's a little alligator. Alligator bracket. This is older, and Harper's shaking his head. It's like, I didn't know you did alligator brackets in C# from like 20 years ago. Yeah, I did. It's still out there, Harper, unfortunately. This is what's called web forms. This is an obsolete, or should be obsolete, technology written by Microsoft. See these special tags? That is like their dynamic pieces of their web page. That's all they're doing. They're saying, oh, I'm going to let you drag and drop something into this page, is what they used to think was cool. And I'm going to make HTML for you, developer, because I don't trust you to understand how to write HTML. Okay. Eventually, everybody picked up what HTML was. So it's intermingled. So that's normal HTML, and that's like a dynamic piece. That's like, think of that as your alligator brackets.
That's how I've done it before, like drag and drop the HTML elements. So
Scott's saying, I recognize that. You can drag and drop a thing, and it'll render it to HTML when you... All that was is a view. A view on the server side that says, I'm going to run some code to interpret that little thing into flat HTML, CSS, and JavaScript, because the browser doesn't understand anything except those three. Now, you've heard enough about me pontificating. Any questions? Richmond or Winston-Salem? Because the next thing is, you're going to go off and you're going to rebuild the API voting application from scratch with a MongoDB database. And then we're going to come back and we're going to talk about what you did. That's going to be a fully functional application. And once you do that, this afternoon, you're going to build an entirely functional application. It could be very simple. Start to finish in Node.js, front end, middle tier, and database, using either non-relational or relational. I've got an example of either one. Questions about the concepts? Question?
Did we ever finish up doing the Git to get the node down? The last thing I remember you saying is that the instructions that you wrote didn't follow step by step.
What task are we talking about, Jenny?
This was a couple of hours ago when we were trying to get our Node 1 folder set up under Empower.
Oh, Node 1, let's see. I don't know. Did we finish that? N1, Node 1. No, we just created Node 1. We never did anything, huh?
Right.
Let me, actually, let me get you started, because that's perfectly relevant.
Had to go over Mongo.
What's that?
Harper's had to go over Mongo.
Mongo.
What about Mongo? Oh, go over Mongo? Oh, review Mongo? Okay.
Isn't this to get them done?
MongoDB, yeah, Harper is saying, yeah, you're not quite done, Allie. MongoDB is a non-relational database. Let me show you what it looks like. What have I got installed here? Probably Compass. So this is, and there are several, there's something called 3T, which is another equivalent of SQL Server Management Studio. This is a database front end to a specific database platform called MongoDB. And it is non-relational, which means, let me show you what that looks like. You're going to do this, so don't worry about following along. It's in the instructions. There's like 25 instructions step by step. You're going to do this in a minute. So this is the user interface, one user interface for a MongoDB database cluster. So this is a non-relational database out there, another platform, kind of like SQL Server, or MySQL, or PostgreSQL, but they don't think about the world in the same way. They don't believe that you should structure your tables with lines and you shouldn't spider it out like we've learned to do in relational database design. So all of that stuff, put it on the shelf for just a second. All of that's correct, but there's more than one way of looking at the world. These guys came up and said, you know, I don't really like doing joins. I don't like making what should be simple in my mind really complicated. These are the guys who don't like sitting down with a piece of paper and drawing out 20 boxes and relating them. They don't want to think about a single one-to-one, one-to-many, many-to-many. No, they don't want to do any of that. So what they did is, wouldn't it be just simpler if I took my JSON object, that's a big list of arrays and properties and nested objects if I want, and I just save it. And when I want it back, I'm just going to go read that again. In order to do that, all I really need is a unique identifier. Something that I can go, you are document number 3272. Later on, I'm going to go find you as 3272. I'm going to get you from the database. It's going to be super quick, by the way, too, because I'm doing one lookup by ID. Give me that whole nasty mess of data. And I'm going to go do that, and I'm going to have fun with it in my web application, and I'm done for the day. I don't have to worry about database at all. There are pros and cons to that approach. In the real world, you don't get just one document. Even in the real world, think about Facebook. Facebook, I guarantee, is non-relational, simply because of its size. So Facebook, well, they probably have multiple databases, but its primary data store is probably non-relational. So when they have a person, you have a profile document. That is probably one document. In that profile document, you have your security settings, you have your preferences, You have things that are really your first and last name, I think it's your birth month, all the things that you get for Facebook, including arrays. Think about what's an array on your profile on Facebook.
Pictures, whatever you upload.
Maybe a link, like a list of URLs for all the things you've uploaded. What about your friends, though? You can't really store friends in your document because you could have lots and lots of friends. And friends have friends. So it really needs to be its own thing. Whenever it's its own thing, let me introduce a term here. In non-relational database design, you're going to build this database called API_votes. I'm going to click on it. Each of your tables are called collections. Okay? So thinking about the Facebook model in theoretical non-relational database, your profile would be like one collection. This would be like people or users. Inside of there, each document, let's look at a document. Each document is going to be a collection of properties. You know, some people on Facebook 1.0, does anybody know where Mike Zuckerberg went to school and where he started this up? Was it Harvard? Yeah. So he, 1.0, those users probably had a very small profile. It was like, he did it, you know, he got it out there and he started it. He might have had like their phone numbers. Okay? Here's the good and bad of non-relational databases. What in the world did I just do? I added a field to one record in a collection. You can't do that in a relational database because all the rows in the table have to have the same structure, right? Well, back in Facebook 1.0, they had more fields, or they had fewer fields. Those records, those documents in this collection, rows in this table, might be different. So you don't have just a rectangle. You have like a jagged list potentially, depending on the structure of that document in that collection. There are pros and cons to that. The pros are you don't have to worry about your database structure. You don't even have to tell your database about your structure. You just send it a JSON object. It's like, I want you to store that. Don't talk back to me. It's not going to talk back to you. It's going to take it. Where is the complication coming in? When you have code that reads from this collection, your code has to know to either look at the phone number field in this example or not expect one and behave appropriately. What happens if you've got a Facebook 1.0 user that has a phone number? There may or may not be a place on the user interface if you deprecated that feature. So your code needs to understand that. So it makes your code more complex to be able to interpret what data you're getting back. Let me tell you why people do this. Why does Facebook, why would they have to do this? Because if you're talking about billions or trillions of records, and we're talking about that with Facebook or some of the other large web platforms, relational databases, as much as it pains me to say, do not scale out well. Scale up, scale out. Scale up means you have a web server that has 10 cores on it and 50 gigabytes of RAM. Scale up means you're going to double down and pay more for a double-sized server. You buy a bigger server, or you buy a bigger cluster of servers that behave as one. You spend a fortune in trying to get that as fast as it needs to be, and you're quickly going to run out of money and resources. They don't make servers big enough to house the database to run Facebook data. It just doesn't exist. Supercomputers would probably choke. They're just too much data. They want performance that's too fast. So another way to do, instead of scaling up and spending more money on a bigger server, another way is to scale out, which means make a cluster. Add a lot of little computers that each of them have a copy of the truth. So when I go to Facebook, I don't go to one centralized database with the other trillion users. I go to any number of hundreds of servers that have a replicated copy of the truth. And it doesn't matter which one. I can go to any one of them, and I can get my profile. I'm going to update my profile, change my last name, change my phone number, save. it goes to any one of them again. And MongoDB will take the change at one node, and it'll replicate to all of the others, kind of like whispering to all of its siblings. This is the truth. This is the truth. That's called eventual consistency. That's the way non-relational databases pull off the magic of handling trillions of transactions. That's if you're going to build a viral application on the internet, you need to think about not being relational unless you have a lot of money. Because you can only scale up so far before you reach the limit of technology and hardware. There is a technology called sharding that is complicated and difficult to set up and difficult to keep running properly in relational database design, to the point where people don't even try it most of the time. There's a very good company by the name of Teradata that they do it that way, where you have kind of this copies of things, and they have multiple copies, and it'll present to you as one big server, and you can have 100 different servers really, but it pretends to be one. Teradata is the only one that really does that well, and you pay a fortune for those licenses. Instead, you could go non-relational. MongoDB, CouchDB, Harper could probably list you 10 of them. Cassandra. NoSQL is a synonym for non-relational. So people say, oh, this is a NoSQL database. Why is it called NoSQL? Because you don't write SQL to talk with these things. What do you write instead of SQL usually? JavaScript. So if you like JavaScript on day 2, you're probably saying, thank goodness, I don't have to learn SQL. I don't have to learn any of this other stuff. I just know JavaScript, and I can do it on the database tier, on the middle tier, and the front end. Job done. Thanks, Allie. See you next year. In the real world, not all applications are non-relational. And here, that's the good news. If you're going to go viral and you want to have trillions of records, non-relational will take care of you. No problem. What's the penalty you pay? You don't get joins. Let that sink in. So let's go back to my example of I've got a profile document and I've got friends. Well, those friends have their own profile documents. And I've got to have another, well, I'm calling it a document, that's like a row, a record in non-relational speak. So I've got different collections, probably people, I probably got friend relationships, I've probably got pictures, I've got different collections. So when you render a Facebook page, in order to get all the data on that page, in relational design, I just do an inner join, inner join, inner join. I've got one query. There's all your data. Smush it all together, you got your data. Non-relational, what do? I'll show you what you do. And it's not pretty. Let's go look at the application we're about to build, which is the API voting application. And I believe in routes, maybe? Maybe here. Okay. Let me open that in Sublime. It looks prettier. Okay. So, Node is going to talk with the non-relational MongoDB database. Okay. Where you would normally do a join, we just learned what a route is. So this is a get for tally. Remember when the day you were doing a jQuery and you were playing with the API voting? This is the back end that you were using. I wrote it in Node, and now you're going to see the internals. You're going to rebuild that yourself in about a minute. Well, between now and lunch probably, and after lunch. So I'm saying, I'm talking about a collection called vote, and I'm going to find it. And we've actually got this up over here in MongoDB Compass. So I've got, let's go over here. I've got a vote table. It's a collection. The word in non-relational is collection. And it's got a bunch of things in it. These are like foreign keys, right? Vote ID, API ID. And it's got a primary key, _ID. You get that for free in MongoDB. It'll generate it for you. It doesn't even ask you if you want it. It's like you're going to get an _ID. So that's your primary key. You got the equivalent of like a foreign key. These things are unique identifiers. Think of them as like your integers. That's the way they do it in non-relational usually. They generate a unique code. And that is like a version. You get that for free also with MongoDB. So that's what I'm querying here. I could pass JSON here, just a JSON object, raw JSON object. And I could say, I want you to filter on voter ID XYZ. That is the equivalent right here in non-relation of saying select star from vote where voter underscore ID equals XYZ. That's how you say it in JavaScript talking with a non-relational database. This, if I don't pass anything, says select star from vote. And this is like pressing F5. Execute. What is this? You know JavaScript. This is a callback function. You're saying, go run that. Oh, when you're done, let me know about it. And give me my results. So it gives you your results. This is unfortunately common in Node.js. So this is, I'm telling you all the bad things now about these technologies I just got you excited about. Node.js is littered with callback functions. So this is kind of how you write Node.js. You specify a callback function, and by definition, the Node.js developer said, oh, we have a problem. How do we catch errors if we're asynchronous? How do we let people know that there was a problem and they shouldn't continue? Unfortunately, they've come up with a standard that says, we're going to pass you back an error object, and if you didn't get any errors, it's just going to be null. That's the standard. That's the tradition. So Node.js, you're going to see this all over the place. So by convention, they pass you back. The first parameter is going to be, if there was an error, here's all the details about the error. So the first thing you do is, do I have an error? And if so, jump out. I'm done. It's just it's noise, okay? Here, this is just pure JavaScript that I wrote from scratch. You can understand this. What am I doing there? 26.
Creating an array.
I'm creating an empty array. Then you've seen a for loop. You know what that is. I'm just saying, for all the votes we got back, which is an array of objects, let's go look at them. Now vote, here's where, getting back to why non-relational has some problems. I'm going to go back over here. This is what you're going to get back. You don't have any data there. All of a sudden, the dream of non-relational store one document, you get it back, you're super fast, we defeated it. Because we have, the non-relational database design guy was like, you did that wrong, Ali. You shouldn't have designed your collection like that. I did it for a reason. To show you that in the real world, this is where you end up in non-relational if you're not careful too. So all I've got are a primary key equivalent and two foreign keys. So that's what I've got in my array here. See, that's where I'm talking about it. In JavaScript, that's where I'm saying, this row, API ID. What am I doing? I've got to go write a whole bunch more code to go, that API ID, I really want to see the API. So I've got to go, let me go find it in my list. I'm writing all this code from there all the way down. It's like, oh, I also have to go in, once I've got that, I've got to go resolve a tally row. What in the world is resolve? No, sorry, that's a promise. That's built in JavaScript. API find by ID. So once I've got my API, I've got to go back to Mongo. So you've got to run 3 queries. I've got to run 3 queries against my MongoDB database to put together manually this pretty JavaScript that says who voted for what. And in SQL, it would be one select statement with 3 table inner join. I'm having to write everything from here, line 46, 23 to 46. All of that goes away with a relational database in one query. You just get your results, format as JSON, you're good. All of that is, you've got to do your joins manually in code. And that's no fun. So, that's the worst part. Most of the time, you're not doing that. Like, who voted for what? Okay. Let's see what we're doing here. We're doing a select star from vote equivalent. Get the votes back. And map. You're going to become much more proficient, much more proficient with JavaScript than you were before. Because on the server side, you've got to play with the for loops. You've got to play with these little functions called map. You're going to want to include _JS to make things a little bit easier for you. We're going to see that later on. For now, I want you to take a peek at this. Don't be frightened by not understanding every line of code in here. I want you to understand the basics like this. What am I doing here? What's going on there?
You're doing a get for the list of APIs?
This is, somebody has requested / APIs on my web server, and this is the function that runs. What are we doing here? That's a query against our MongoDB database. Select star from API. When we get our list of API records back, what do you think that does?
It turns it into a JavaScript.
It says, send it back. Send it back as JSON, just a JSON array. Why would we do that? Doesn't the browser and normal people want to see HTML and CSS? Remember, this is an API. You were consuming this from your jQuery. So your jQuery spoke JSON. So we could send back whatever we want. So this is how we gave you back your list of APIs. This was actually the first call. It's like, give me the list of possible APIs to choose from. That's where you get it from. Simple and beautiful. 4 lines of code. So there is a step-by-step list of instructions on how to do this. And I posted it into questions. One last thing about non-relational. Unfortunately, developers tend to be very opinionated. If you talk with a relational database developer, he is going to go off for an hour about how non-relational is horrible. If you talk with a non-relational database designer, he's going to go off for an hour about how relational sucks and it's obsolete. Who's right? Neither one of them. Choose the right tool for the job. So there shouldn't be an argument. There are pros and cons on both sides. Let's talk about, I think it's way up here in questions.
Empower.
It's in Empower? Thanks. There we go. Empower Public. Download that. Take a look at it if you haven't already. Step by step, I want you to go through. This says, oh, here's how you create a new GitHub repo. Here's how you download and install this stuff. Step by step with screenshots. This is, I told you I was going to sit down and do this on a Sunday afternoon. It's like, oh, it'll take half an hour. It took half an hour to write the app. It took 6 hours to write this documentation. Okay? So please go through this just for my own psyche. It's like, I did it for a reason. Follow these instructions. So let me explain a little bit what's going on here. So npm install -g express generator. You know, Kathy, back to your question about node 1. That's the step 1 in this document. Instead of creating our own little node 1 web server, what we did is instead we went to very simple web server and we opened the existing code that I wrote before, so we're not going to do that. This will walk you through how to create a directory from scratch. npm, I completely glossed over that. npm is called Node Package Manager. That is, you know, before in jQuery we had to go to the website, get the Git repository, download, or copy and paste a file and put it into our folder. Node developers said, we're going to do that all the time. Let's create a little something that's... You have a question? Go ahead, Mudit.
Does Mongo run on port 3000?
Mongo does not run on port 3000. I think it's...
So where is that defined in this? I don't see it.
Are you talking about the example application we're about to build?
Yeah.
Okay. So the example application we're about to build, you may wonder, he's done it already. He did that this morning. He's jumped ahead. It is in www port 3000. So there's no magic. Getting back to MongoDB, where does Mongo run? If I say connect, MongoDB has its own port, just like everything else. It's some very high, it's like 11,000 or something, 12,000. As a matter of fact, we can go look at our connection string. Somebody asked me about a connection string yesterday. There is a connection string for any application that connects to a database. And in here, I believe I put it in, yeah. So Mongo's port is 27017. This is our connection string. It's big and long and nasty. Fortunately, you don't have to type that. you can copy and paste it, and that's part of the instructions. So getting back over here, what are we doing? We're following the instructions, start to finish, Node with Mongo from Slack. It's going to walk you through things. You're going to see a couple things that I haven't explained in detail. NPM. NPM is the Node Package Manager. You can check and see that it exists and its version by saying -v. NPM install means I want to download and copy the library locally to a little subdirectory called node modules. So when you say that, it throws a bunch of stuff in here for you. No magic, it just downloads it and installs it for you. And if you want to see the code, right there it is. This is what you got. Somebody wrote a whole bunch of JavaScript for you. And in JavaScript, they don't hide anything from you. It's a black box theoretically. You want to peek in the black box, go ahead. I wouldn't do it if I were you, because it may help you realize that there are some really sharp JavaScript people out there, and you're not yet there yet, myself included. But you download, so when you say npm install this package, it puts it in a node modules directory and all of its dependencies. Where did the dependencies come from? I'm also glossing over this. There is a npm init. When you say npm init, in step 3, you're saying Node Package Manager, I want to initialize a new application. And it's going to be very nice. It's going to walk you through, and it's like, I'm going to prompt you with little inquiries. What would you like to call your application? What is the description of your application? What is the first file that I should run for you by default when you run your application? What's your Git repo? And so on. And I'm pointing out this is how you respond. If you don't know the answer, don't worry. It's just a helper. Just just type enter, and it'll take a blank. Express, I told you that that's a slightly augmented node.js web server that does some nice things about interpreting the web request and giving you variables and running a view engine. That's all you have to do. This is how you say EJS. That means alligator brackets. By default, I believe it's Pug, or what used to be known as Jade. This is your application name. So npm, nothing to be afraid of. It's a helper application that allows you to download and install packages, libraries, for JavaScript. That's all it does. You're going to quickly have a bunch of generated code. So here, we're saying, oh, let's go install a couple more packages. Mongoose is a cute name for an ORM to MongoDB. What is an ORM? Anybody ever heard the term? Object Relational Mapper. That means I've got a database and I've got records, but I talk code. Code doesn't understand what a record is. It doesn't talk SQL, to Anna's point earlier. It talks JavaScript objects. An ORM, Object Relational Mapper, says, you know, everybody has this same problem. Let me be the interpreter. Let me take your rows and I'm going to make them JavaScript arrays for you. You don't have to do that by hand, thank goodness. So Mongoose, it's a cute name. You'll find open source has really cute names. Mongoose is the ORM that allows you to talk from JavaScript, Node.js, to MongoDB. It is the interpreter between the rows, the objects that come back from Mongoose, and it gives you arrays of JavaScript objects for you having to write no code. It does that for you. So that's why we're installing it here. You're going to hear about ORMs again. We're going to use an ORM with SQL when we talk about C#. There are two ORMs that are common, Entity Framework and Hibernate. You're going to talk about that with Derek and Paul. But I'm giving you a preview and letting you know, remember ORM, Object Relational Mapper. That's the interpreter between your data from your database to your code. An example of that, this find method, that is Mongoose. Mongoose gives you that function. So it does all of its code inside that find method to query, interpret, and give you back the results. So there's like 20 steps on how to go and create a new MongoDB database. At the end of it, you're going to see something that looks like this. You're going to have an API votes database. And inside of your database, you don't have tables in non-relational. What do you have? What are they called?
Collections.
Collections. And collections are made up not of rows, but what do they call them? Documents. Documents. It's also, instead of non-relational, Mongo is also called a document database. What's the big deal with non-relational? You can do things like that. You can have a jagged definition. You don't have to have all the same definition for all your documents in your collection. Okay. Any last questions? Because you're going to go ahead and do this. You're going to take lunch. You're going to come back from lunch, and we'll start back at like 1:30, and we're going to see how it went. And then I'm going to show you how to do Node.js with relational. So you're probably thinking, oh, we just spent days doing SQL and relational database design. You're going to throw all that away? No. You can do Node.js against a relational database too. Whatever flavor you want. MySQL, PostgreSQL, SQL Server, we're going to see how to do that too. And that's where you're going to have the option as of like 2:30. The rest of the day, go run with it. Build a relational database and or a MongoDB database and build a very simple Node.js app with a full front end that works. So that'll be from like 2:30 on. Any questions before we go do this and go build your API voting thing with MongoDB? Question? A jagged definition? Let me show you what a jagged definition is. We are inside, the question was, what is a jagged table definition? So this is API votes.api. So API is the name of my collection. API votes is the name of my database. This is a list. So you can kind of see there are 3 properties here on the first document. There are 2 properties on the second one. If I do table, notice it's jagged because this has a property that none of the rest have. So if you were to draw a line around the edge of the rows, edge of the documents, it would look like that. It would be jagged. Because I could come down here and I could go to GitHub, that record GitHub, and I could change it, and I could, how do you say that? I'm going to say value, no, it's wanting me to, I need to do list to be able to do that. So let's go down to GitHub, and I'm going to edit it, and I'm going to add field, and I'm going to say URL. Very good, thank you. And I'm going to throw in our GitHub URL. I'm not going to bother. Okay, and then I'm going to update. So I've got a brand new, what would be a field in a relational database, and you couldn't do this. Look what we've got here. I've got this property that only exists on this one document. And I've got this property that only exists on this one. And none of the rest have either one of them. That's what I'm saying jagged. It's not all the same for the whole table. Relational, it's always the same all the way down, all the rows. Okay, any other questions? Richmond. Nope. Hopefully that means they understood, and that means they haven't committed mutiny. So. I like the way you're thinking, Jamila. Jamila's question was, what would happen if somebody built a relational database and then they had so much success that they couldn't handle it anymore with performance and they had to convert it to a non-relational? And the answer is yes, that has happened many times. And the answer is a complete database rewrite and a data migration from relational to non-relational. But by the time you need that, you have so many millions flowing in through the door, so you just hire developers to go do that for you. So now she's asking about how much would it cost and how many hours. It really would depend on how big and complex your application is. If it's something like Twitter, I'm sure Twitter planned on being big because lots of small messages, but you're talking billions, they probably planned on non-relational. But let's assume Twitter was like that. They would have had a fairly small set of data, just lots of it. It probably wouldn't take too long. Because you got like, what, 4 or 5 collections? 4 or 5 tables that you need to make collections? Okay, pretty straightforward. You could do it with 1 or 2 people. If you've got Facebook or something that branches out and it's really complicated, it's probably going to take a while. But the good news, once again, if you have that problem, you've got the money to pay for those people to go take care of it. Relational take care. When I say big, I mean billions or trillions. And I know we all like to aspire to have the next viral app. You're going to be fine with relational 99% of the time. Okay? I, confession, have never built a non-relational database that was necessary. I built it sometimes just to have fun. It wasn't necessary. I've never had a successful app to that point. Any other questions? Okay, go to it.